Hello guys and welcome to it. So today we're going to be doing laws of exponents, and the first one that we're going to be dealing with is law 1. And law 1 is based on the product of powers, and it goes as follows. So if I have two bases, similar bases that is, so if I have this base, okay, before I explain this, let me start off by making you understand the difference between an exponent and a base. So this, if I have a to the power of, for example, m, a is known as my base and m is known as my exponent, right? So this whole thing is known as a power, okay? But that's not really what we want to learn. I just want you to understand the difference between a base and an exponent. So a base is usually at the bottom, and then an exponent is at the top of your base. All right. So now that we have that out of the way, it's time for us to now get into the laws of exponents. And like I've said, I'm going to be explaining law 1 first. So if I have a to the power of m multiplied by a to the power of n, the laws of exponent, law 1 of our laws of exponents says that if I have two similar bases, right, multiplying each other, then my exponents are going to add. I'm going to repeat that. If I have two bases which happen to be the same, then my exponents are going to add. All right. So this means that these two bases that are multiplying each other will give me a result of the exponents adding to each other under the same base. Because I have a similar base of a, it means the exponents are going to add under the same base. So the result here will be that I will have a, which is my same base of a. I will have my exponents adding under this particular base. So it means I'll have a to the power of m plus n. So that's what the first law of exponents actually means, that if I have two similar bases that are multiplying each other, then the exponents of those bases are going to add under one base of a. In this case, since my base is of course a. All right, so that's how you explain this. Now let's further go on to our examples. If I have, for example, a to the power of 3 times a to the power of 2, what this means is that because I have two similar bases that are multiplying each other, my two exponents are going to add under the same base of a. So the result here will be a to the power of 3 plus 2. Now we have to simplify this further. So if we simplify it further, it will end at a to the power of 5, because we would have added 3 plus 2, which will result in us getting 5. So the whole result will be a to the power of 5. All right. And what this means, if I have a to the power of 3, what this means is that I actually have 3 a's, and on this side I have 2 a's. So what this means, this is just for the sake of you knowing. It's not that maybe you need to actually show this unless you are instructed to do so. But what a to the power of 3 means is that I have 3 a's. So I have a times a times a, right, multiplied by this this power, which is a to the power of 2, meaning that here I have 2 a's. So I have a times a. All right, and the result will take me back to, this is a to the power of 1 to the power of 1. This is basically me saying a to the power of 1 plus 1 plus 1 times a to the power of 1 plus 1. Why am I saying this? Because this a to the power of 1, this a to the power of 1, this a to the power of 1. So because we have three bases, similar bases that are multiplying each other, the exponents add, which gives me this, and then from there, when I simplify here further, I have a to the power of 3 multiplied by, on this side, this a to the power of 1 and this a to the power of 1. When I multiply two bases with when I multiply two similar bases, the exponents add, which is the case here. 1 plus 1 will simplify to a to the power of 2, and this will simplify further to a to the power of 3 plus 2, and the final result will be a to the power of 5. Okay, but the one that you really need to understand is this one. That's the most important part, and you will see as we go through other examples as to how you go about solving this particular problem. Let's look into other examples, shall we? So if I have a to the power of 4 multiplied by a to the power of 2, what this means is that the result I'm supposed to get is, because I have two bases of a that are similar to each other multiplying, then the exponents should add under the same base of what? A. So this a to the power of 4 times a to the power of 2 gives me the result of a to the power of 4 plus 2. When I simplify this further, it should give me a to the power of, when I combine 4 plus 2, I get 6. So this becomes my final result. So because I have two similar bases multiplying each other, then the exponents are to add under the same base of a, since in this case my base is a. And when they add, after being simplified, they will add up to 6. So my exponents, when adding up to 6, give me the final result of a to the power of 6. Let's do more examples. So the other example that I have is, if I have a to the power of x multiplied by a to the power of y, then my result here should be that under the same base, since I have two similar bases multiplying each other, under the same base, I will have my exponents adding to one another. So I will have a to the power of x plus y, and this becomes my final result. Okay, and then when we go further on another example, if I have a to the power of x multiplied by a to the power of x squared, then my result, because I have two similar bases multiplying each other, my exponents will add under the same base of a. So my result here will be a to the power of my exponents adding to one another. So my result will be a to the power of x plus x to the power of 2. All right. Now, the reason why we're not adding these further is because they are not like terms. If they were like terms, then it means we were gonna add them together to get one final answer. But because x is not similar to y and y is not similar to x, we end up only at x plus y. The same applies here. We have x and then we have x squared. You cannot end up having 3x, for instance. No, what you should have is x, because what you should have is x plus x squared. All right, because x is different from x squared and x squared is different from x. Okay, hence our answer only ends here. All right, now let's do more concrete examples other than this one. But I'm hoping that thus far you happen to understand what is what. Okay, let's look into more examples in the next video, I think I should say. So we're gonna do more examples in the next video based on law 1. For now, please do like the video and of course subscribe to the channel. See you in the next video.